KNearest Neighbors classifier. This is another classifier of the machine learning. In this session, we are going to talk about the KNearest Neighbors, or KNN. You can also call it KNN classifier or KNearest Neighbors classifier. We will check it theoretically and graphically, and then at the end we will do a project in Python using the KNearest Neighbors. But the first thing is to do the introduction to the KNearest Neighbors. What is KNearest Neighbors, or what is KNN? What kind of classifier is this? What we mean by KNearest Neighbors? We can write KNearest Neighbors or KNN is a classifier which classifies the data based on the number of the nearest neighbor data points. KNearest Neighbors or KNN. In short, you can say that KNN, N for the nearest and N for the neighbors. KNearest Neighbors can be written in short KNN. It is a classifier. It is a classifier which classifies the data. It classifies the data based on the number of the nearest neighbor data points. It's pretty much clear from its name, KNearest Neighbor, nearest neighbor, which means that the data will be classified based on the nearest data points. For example, if we have two classes of data, and if you want to put a new data there, if the new data has more nearest neighbors from class A, it means that this new data belongs to class A. So it depends on the number of the nearest neighbor data points. We will check it graphically. We will see everything in the graph. Just stay tuned. In KNearest Neighbors, K is closer data point of the data. The larger is the K, the better is the classification, but too much large, K misplaces the locality. Look, in KNearest Neighbor, this K is actually the closer data point of the data. This K stands for that data point number, that close data point number. It determines with the K. That's why we call it KNearest Neighbors. So the larger is the K, the better is the classification, which means that if we have more nearest neighbor points, the more we have the nearest neighbor points, the better this classifier will do classification. But remember, too much large K, which means that if we have a lot of nearest neighbor data points, then it can misplace the locality of the data points. It will mix everything and will misplace the locality. It may disturb the locality of the data points if you connect a lot of neighbor data points. So it shouldn't be too much. In fact, if we have more nearest neighbor points, the classifier will do good classification. But if you exceed it further, like if you do too much, for example, if you put a lot of nearest neighbor points, it may misplace the original locality of the data points. Everything will be mixed. There will be confusion for the classifier. As I told you, K is actually the closer data point of the data. This is actually the closer data points. It shows the number, this K shows the number of the nearest neighbor points. So larger K means more nearest neighbor points. Smaller K means less nearest neighbor points. I repeat this thing. If we have a larger K, which means that if we have more nearest neighbor points, this KNN classifier will do very good classification. The classification will be good. But make sure it shouldn't be too much. Too much large K can misplace the locality of the data points, which means that if you connect a lot of nearest data points, it will misplace the locality of the data points. We will check it graphically later, that what is K, how we can draw the K, how to choose the K, why proper K is important in KNN classifier.